Good evening. Welcome back to my weekly Node-RED development live stream. I hope you're all well. I hope you're doing okay in these times. So let's crack straight on. Softy2k, great to see you in the chat. And yeah, if you're in the chat, do say hi. If you're watching on YouTube, do drop a comment, drop a like, whatever you want to do. And yeah, let's crack straight on. What are we up to tonight? We are going to be carrying on what we were working on last week, which was the some tools to help aligning nodes in the editor. And we're actually going to do the next piece, which is distributing nodes. So again, very familiar tools in apps like PowerPoint and the like that let you let you align things, let you sorry, let me just reduce the lighting. Is that any better? Sorry, feedback on the chat, but I'm a bit overexposed. If I drop that one, so I don't get the glare behind me. That's looking a little better. There we are. Align tools. So we did, let's pull this up. Last week we got to this point with this pull request, adding in a bunch of actions to align nodes to their left, center, right, top, middle and bottom. One thing I did do after the fact was I went in, the PR you saw me do, or the code you saw me write, all these actions were called align nodes to left, center and so on. I've renamed them back to align selection, which makes it fully consistent with the the action we already had, which was align selection to group. So what we're going to do, we're just going to carry on. We're going to carry on because this was quite fun stuff to do. Before I say that, I will say some feedback we've had, some questions we've had about these Twitch streams, and if there's any way to find out what all the previous streams cover, because there's quite a lot of them now. There's, where are we? This is our 45th stream. And something I'd always intended to do was make sure we had good notes in the descriptions of every video so that it'd be easy for people to go back. Unfortunately, I never got on top of that. So what I've started this afternoon is a Google spreadsheet to begin with, where I am just listing out all the videos and at least getting a description for what that video covers. And I've got through the first, 24 of them. So I'm just over halfway through. And yeah, I'll figure out some way. At the very least, I'll go back through the videos and add this description to the description of the videos. But I think it'd be useful to have this somewhere where people can browse it more easily. Indeed, having it somewhere where other people could contribute and add in even more descriptions if there's other useful bits. I don't know. But yeah, that's happening. It's just a little, just a chore to go back through. So for the third time, let's just crack on without getting distracted again. So adding more actions to the editor. Let's pull back up the code we had before. So here we are with view tools. So we're in at Node-RED, editor client. Editor client, source, JS, UI, view tools. And somewhere in here, go to align selection to edge. So this is what we spent an hour last week writing, was all of this code here. So tonight we are going to add two more. We're going to add a line. We're going to do distribute selection. I think we're doing it this way. Let me just pull up for reference. Arrange, how do they describe it? you have align. So they just call it, yeah, distribute horizontally, distribute vertically. So let's not get fancy. Distribute selection horizontally and distribute selection vertically. And we're going to call our function exactly the same, distribute selection. And we're going to pass in either H for horizontal or V for vertical. Just following this pattern of having sort of, because we know from experience the code is going to be 80% the same. So let's set ourselves up. Hey Board Geek, welcome back. So yeah, so what we're working on here is some tools in the editor. In fact, let me just pull up the PR number. So pull request 3110, if you want to go look at that. This is the work we did last week. So some actions in the editor to let you select some nodes and then align them all to an edge, top, middle, bottom, center, whatever. And tonight once you've selected a bunch of nodes, do distribute them horizontally or distribute them vertically to help lay them out. Okay, so this is the code we had from last week. Again, I'm gonna just copy the whole function because it's the right skeleton for what we want, if not the right logic. And distribute selection, that's what I called it, wasn't it? Yeah, that's what I called it. Direction. So let's just go over again what this code does. So it asks the view to give us the current selection, because we're only worrying about nodes and groups rather than tabs. We check we've actually got some nodes selected and that we have more than one, because there's no point doing any work if we've only got one thing selected. We want to keep track of any nodes we change because of this action, because we will have to be able to undo it. Now, this is where we start getting into the logic for aligning to an edge. What we need to do, let's think about what the actual work is now. So given, in fact, okay, no, I was about to, so given these three nodes, okay, what we want to do is we want to find the leftmost midpoint, the rightmost midpoint, and then we want from that to calculate what the midpoints should be of all the nodes in between. Now, that makes me realize if you have two things selected and say distribute, there's nothing to change because these two are sort of the anchors on the outside. So this line when we said we only want to do the work if we have more than one thing selected, really it's we only do the work if we have more than two things selected. So the first task is to find what is our leftmost center and our rightmost center. In fact, this bounds object, we can pretty much do the same thing. One difference is now we're not interested in sort of the bounding box, we're interested in the centers of the node, I think. At least that's what I'm going to start with, and we'll once we've implemented that and we'll try it out, we'll see does it make sense to use the centers of nodes. I think it does. But okay, so this is going to be our center points, and so we want to find the minimum xy and the maximum xy, because don't forget we're going to be reusing this for both horizontal and vertical, so we're sort of implementing both at the same time on the two different axes. So we'll ignore the group case for a second. Let's just, for regular nodes, we want to find the minimum x. Now, because we're now doing the centers, not the edges, we don't need to take into account node heights and widths. Okay, and then when we go up and look at groups, we now do want to take into account centers. And because groups, a node's x and y is at the center of the node, a group's xy is in its top left corner. So if it's a group, then we want to find its center, which is that, but it's that on both axes. Okay, so this is now going to find our minimum and maximum centers. So purples for the selection node, like, shouldn't be if more than one node is selected. No, you see, I've just changed that. You may have missed it. So I've changed it to 2 because if I've got 2 things selected, then there's nothing to distribute because these 2 nodes define the anchors. And what we're actually doing is distributing everything in between. So to do any work, you have to have at least 3 things selected, 2 of which will be the anchors, and then whatever's left over will get distributed in between the 2. All right, so we've done all that. And you know what, the logic is actually subtly different, because whereas before, when you align to an edge, it doesn't matter where the node is currently, you're just moving it to line up on this edge. Now we're distributing it. There's a subtle bit of behavior that we have to get right, and perhaps it'll be easier to explain what I'm thinking of. Here, let's look at these guys. I mean, these are already fairly well distributed, but so if I select these nodes, and remember, I could select them in any order. You can't assume that this inject node is the first of the selection, this debug's the last. So when you distribute these nodes, you don't want these 3 in the middle to reorder. They've all got to stay in the same relative order to one another, but they just have to nudge around. And that's got to be true. There's an interesting edge case of what happens when you have that, where these 2 nodes are actually already in the same X position to begin with. Where I suspect we'll get to tonight is code that could end up redistributing them to look like that, because it's just treating them as putting them in the right order. And when you have 2 that are in the same starting position, you've got to break the tie and decide which one gets moved. And that's also going to be true of if you have 2 that have the same starting point. Now, out of interest, if it's always useful just to go and get a frame of reference of behavior. So let's just create some squares. And I'm going to colour them so that we can colour them differently so that we can follow them if we move them. Okay, so I don't think it's controversial. You select those, distribute horizontally, and the blue and yellow didn't move. These 2 in the middle did. Now, if I line those 2 so they are in the same position, and now I do align, distribute. No, yeah, it's chosen to move the green one. If I put the orange one over the blue, see again, it's decided to move the orange one out of the way. So I don't know if there's just some there may just be some ordering thing here because the blue one I created first, so it's choosing to use that as the anchor. Yeah, anyway, there's some edge cases we may or may not drift into tonight. But for now, let's crack on. What's he saying? Yeah, so if we, just in the chat, yeah, well, I fully believe it is pixel position, that if it's going to be using whichever is the furthest to the left as the anchor. The question is, how does it deliberate a tie where you have two that are overlapping, which, see there, it's kept the blue. The point being that in node red, where we have a tie like this, we actually have the extra information that this node down here its output is wired to the input of this one. So if we need to break a tie, it would make more sense to move that node than it would this node. That's, yeah. In fact, there's lots of interesting behaviours of what if, for some perverse reason, the flow is completely reversed. And if we did this action on this flow, should it try and unwrap? But yeah, I'm not going to get too carried away with these edge cases for the moment. For now, we'll just get carried away with implementing something. So the first thing we need to do is, we need to identify the anchor nodes. Whereas before, for doing the align to an edge, we would calculate where they should be, and then we'd just go through all the nodes and move them if they needed moving. Now it's slightly different in that, having identified the minimum maximum bounds, we actually need to know what that object is at that minimum or maximum, because we need to not try and reposition it and not include it in the set of nodes that need moving. So what we're going to do is, this is the challenge where we're working on X and Y together, because we're trying to write code that can do horizontal and vertical in one go, but only later on do we decide which we care about. Let's how do we want to do this? Right, I'm going to call it start anchors, end anchors. Not sure I like those words, but we'll go with it for the moment. Right, here we're going to say, at this point I need to make direction, need to start taking into account direction, I think. This needs tidying up, but what are we doing? We're going to say if the bounds min x no, right. I'm going to sort of change how we do this slightly to avoid excessive recalculation of all these things. We're going to, depending if it's a group, we're going to use x, ny to store the coordinate of this object that we are working with. Which should become clear in a moment. Okay, so once we've done that, we can here we can then use that nx and my to set the bounds. Oh, don't jump. Sorry. Yeah, use that to set the bounds. Then we're going to say if nx equals bounds min x, oh, we're going to do it this way. No, I think it's slightly inefficient, but we're going to now do a second pass. Do we want to do a second pass? Oh, God. No, we're not going to do a second pass. Sorry, I'm sort of jumping around how to implement this efficiently. So in one pass, we can do this. It's just we can't use this math.min trick. We need some actual if statements because we've got a bit more state to manage. So we're going to say if nx is less than the bounds.minx, so this node is further to the left than anything we've got, we're going to clear out start anchors because whatever state we've already stored as candidate start anchors, we can forget them because we've found something further to the left. In fact, this is where we need to take into account direction. So if direction equals, now did I say horizontal? H and V? H and V. So if we're dealing in the horizontal, then so we found something that's less than the bounds min x. We now take a note of what that is. And we're going to do exactly the same for the max x. And this time we clear out end anchors and we record the max x. What we do here is we now say if, we'll do it the other end. So if the x position of this node is the same as the minimum x we've currently got, then we're going to start anchors.push n. We're going to record that this node is a candidate anchor. And then likewise for the max x, but this time we push. Okay. Yeah. Now we can simplify this. We can make the if statements bigger and reduce the duplication, but I'm just going to go with it this way for the moment. So if the direction isn't horizontal, then it's vertical. Then we just need to swap out all the x's for y's down here. I think that was all of them. Okay. So that's all we do in our loop. So at this point, we should now know what our start anchors and end anchors are. So why don't I do a console.log start anchors. Okay. And then I'll just stick a return in rather than comment all that code. Last thing I want to do is, do I need to do anything else? No, we'll go with that for the moment. So let's just reload Node-RED. Let's go find a, so these three, let's do distribute selection horizontally. Before I do that, let's get the console up. So distribute selection horizontally. There we are. So start, you can see it's found the inject node, good. End, it's found the debug, also good. And for just completeness sake, if I line those two nodes up and select the whole flow and do distribute horizontal again, you can now see start, I've got two candidates, the HTTP request node and the inject. And yeah, I'm not going to worry about that edge case for the moment. So what I'm going to do is say start anchor, just accept the fact that it could be more than one. And for now, in absence of having a better bit of logic to choose which one to treat as the anchor, we're just going to pick the first in the list. If there's only one, that's fine, that works. Yeah. Okay. Next thing we need to do is now get a list of all the nodes we now need to reposition. So what we're going to do is say nodes to move, create this array, and we're going to selection.nodes. I'm aware it is a second iteration over the loop, over the selection. Might be able to shortcut it via a set, but even then we'd need to convert it back to an array, so you'd still have to iterate over the selection a second time. So I think this is probably okay. So we're going to filter our node selection, and we're going to say we want it if n.id is not equal to startAnchor.id and n.id is not equal to endAnchor.id. Okay, so that's now given us all the nodes in between. We are now going to sort that array. We want them in the right order that you want to distribute them in. So to sort it, we are going to base that on its, for horizontal, we're going to, we're going to return a.x minus b.x. So for those not familiar, the sort function on an array, you give it a function, it gets called with a pair of elements in the array. You return -1. I can never remember the right order, the right logic. So I may have to flip this, but you return a negative number if you want A then B, a positive number if you want B then A, or 0 if they are effectively equivalent. So given we're working in coordinates, you basically subtract one's x from the other's x or y, depending on our direction we care about, and that will give you a negative or a positive number based on their natural order. But I can never remember which way round they should be, so what I might do at this point is, if I console.log nodes to move at this point and reload, let's go find a flow with a few things in. Yeah, okay. Let's do this flow here, and we're going to say distribute horizontally. So you can see the start has got the inject node, end is the debug node, and then I've got these three function nodes, but I hope you can just make out their x's are in the right order, 270, 430, 590. So we have sorted them in the right order. If I were to, as a if I were to move this node there and then rerun the action, you see we've still got the 3 here, but now we've got 230, 290, 610. Oops, before that's... Oh, I think I may have nudged them by mistake. The point being, things are... Yeah, I accidentally moved everything, so I couldn't do a like comparison, but the X's are still in the right order. So I've got my X and Y's the right way around for both of these. Good. So having done that, we now know how many nodes we need to distribute. We now need to work out how to allocate the space. So space to fill is, well, if we're dealing with horizontal, then it's going to be the end anchor.x minus start anchor.x. If we're going vertical, then it's the y's. So that gives us the space to fill. Then the space between nodes is the space to fill minus right. So when we've got 5 nodes, we've got 3 to fill in the space, and we'll have 1, 2, 3, 4 gaps. So we want to divide the space to fill by the number of nodes we're trying to position, which is nodes to move length plus 1. Okay. There's going to be something we might want to do here around snapping to grid, but we'll, again, an edge case I'm going to skip for the moment. Okay, so we now know how much space should be between each node. At this point, we can loop through the nodes and move them if they need moving. So how best to do that? We can, because it's all relative, we're going to say previous node is start anchor. And then we'll say while nodes to move dot length is greater than 0, next node is nodes to move shift. Is it shift? Oh, I always go blank on the most basic array functions. So array.shift gives us 1. Yeah, the head of course. Yes, pop is the end, shift is the beginning. I don't know why I have a mental block on that, but I'm sure if you've watched enough of these streams, you would have witnessed my mental block on that before. Okay. So what we can now do is we want to say we need to get the center point of the previous node. We'll use CX and CY, and then we're just going to go and grab, because it's this logic up here. Yeah, I think we might end up with some No, we don't need, sorry, we don't do it this way. This is wrong. So we don't need previous node. What we want to do is we need to have a target X and a target Y. So this is where we want the node to be. And we start with the start anchor and we get its center. And then what we want to do is do another, if the direction is horizontal, then tx we need to add space between nodes. Else if it's horizontal, we need to increment the target y. Then we can come into yeah. In fact, we're going to stick that inside the while loop and you'll see why in a sec. So whilst we have nodes to move, we come in here, we move the target by the appropriate distance. We get the next node. We then want, again, I'm not going to handle groups at this point. I'm just going to get this working for normal nodes, and then we'll have to add some logic here to handle groups. But we're going to say if next node dot, yeah, sorry, because we only care about one axis. So let's just write it out longhand on each axis and then look at, is there a way to make it shorter? So if direction is horizontal, if next node dot x, which is its center point if we're not thinking about groups at the moment, is not equal to the target x, then we want, and I'm cribbing from down here, this is the logic we want, which pushes this node because we're about to move it. We just need to make sure we update these references. We push into change nodes, so because we're about to move it. We then move it. Yes, I'm writing up. I'm only going to deal with horizontal because we're going to end up with a lot of copy and paste in a sec, which I really want to avoid. But let's just focus on getting this right. So we don't want to change the y if the direction is horizontal. And here I've called it tx rather than target x. Okay. So this node is not where it should be. We move it. Otherwise it is where it should be, and that's just great. And then we're going to loop. We'll move the tx, because it's a fixed space between nodes each time. We move that, and then the next node we'll see if it needs moving. Okay. And then I'm just going to scrap all this code down to here. And at this point, this is where we do if change nodes is greater than 0, i.e. we have moved something, we stick it in the change history so it can be undone. Okay, let's see if that does what we think it should. Let's go and find just a simple, let's use this example. Distribute horizontally, and there you can see this node has indeed moved itself to be horizontally distributed between those two. Has it though? Okay, we can use the grid. You can see I've got 3 grid cells that side, and at the moment, because I've nudged it, I've got 4 grid cells that side. So if I do the horizontal, you can now see I've got 3 and a bit, but coming back this way, I've got 3 and a bit more. It hasn't put it... It hasn't done what I would Oh no, right. And this is where this is going to get slightly confusing. Timestamp node here is 1, 2, 3, 4, 5. It's 6 grid cells wide. And this debug node is 1, 2, 3, is only 5 cells wide. So you've got to think its center is about there. And the timestamps node is exactly there on the grid cell. And that HTTP request node in the middle has been put right in the middle of what I'm highlighting there. But that does mean that this wire is slightly shorter than this wire. If I were to make this node, let's give it the same, oops, not Stampy. So now, oh, why has it done that? You'd think with the same, oh, it's because it's italic font, isn't it? Right, so now those 2 nodes are exactly the same. And if I get things back to where they were, so 3 node gap that side, 4 grid cell gap that side. Now if I select all of them and align horizontally, you can now see I've got 1, 2, 3.5 cells that side and 1, 2, 3.5 that side. So yeah, mathematically it is all working. There is, yeah, it's whether aesthetically it works. Snap to grid is a challenge. Well, it's not a challenge. It's at the moment, it's impossible for this node to snap to grid and to be evenly distributed because there's just the wrong number of grid cells between those 2 nodes. If I were to move that one over and then do the same deal, you can now see there are an even number of 4 that side, excuse me, 4 that side, and this node is nicely aligned to the grid. So yeah, I think this is just kind of the nature of what this tool does when you have the grid enabled. I think we will cope with that for now. So what we want to do is add in the logic for vertical. So what do we do? How best to do this? We are going to start by making it a bit more compound. So if it's a compound if statement type thing. So if the direction's horizontal and the x doesn't line up with the target x, which is effectively the condition we've just been dealing with, or all of that except vertical, yeah, so that if statement now captures whichever direction. We know this is a node that needs to be moved. So we store the node because it doesn't have to move. And then here we just need the extra direction check, which I'm just going to again copy and paste there. So if it's horizontal, we do y tx, and yeah, horizontal we just change x, otherwise we change the y. So that's going to handle. So that is now going to handle both cases, which is good. And we can verify that by yeah. I have to admit, distributing vertically is a bit of a, well, no, I was about to do this, but we haven't dealt, we don't do groups yet. So yeah, let's do these nodes and say distribute vertically. Yeah, that worked nicely. It has put this one slap in between those two. Not on the grid, but again, there's just not the right number of grid cells between the top and the bottom for this middle one to align. Where it's going to go a bit haywire is if I select, well, not haywire, it's going to do exactly what we want it to do. If I do that, say distribute vertically, you can see they have all been distributed vertically. They are all, if I were to, anyway, yeah, get carried away. But that's a bad example of where you wouldn't select something like that and say distribute vertically. Now there is certainly something to be said for being able to say, given this flow and this flow and this flow down here, distribute the flows vertically. So separate them out. But again, that's a different action, but something we could think about. What we need to do at this point is to get this factoring in groups. So to do that, we need to, oh, that's right. So if you remember last week, if you change a group, if you want to move a group, you actually have to move all the nodes within it just the right amount. Right, excuse me, just the right amount. So, first thing to do is decide, is this a group we need to move? How did we do it before? Okay, so we made an early decision. Here we go. Okay, what we're going to do is pull out the X and Y coordinate, and we'll say, oh, we'll go and copy and paste. This is group line, because I suspect we might need to test whether it's a group or not a bit more. So if it's a group, then we just need to nudge, because we care about center points. And if you weren't following earlier on, groups X and Y are the top left corner, nodes X, Y are already the center. So there's, yeah, it's just how it works. So now rather than check next node, if we just change this to NX and NY, we'll be able to detect whether it's the group or both groups and nodes, whether they're out of position. It's what we do next that matters. So what this does only applies for non-groups. Else, what we have to do, I'll just go and copy the code because we already had it from last week, although some of the specifics will have to change slightly. So what we do is we get all of the nodes inside this group recursively. That's what that true does. We then need to work out the delta, which is to say by how much are we moving this group? Yeah. So the delta x will be, if the direction is horizontal, then we need to move it by nx minus, and what do we call it, tx. Otherwise, the delta is 0, because if we're not doing horizontal spacing, then there should be 0 change in the x-axis. And I'm just going to copy and paste to say if it's vertical, then it's ny, ty, otherwise we don't care. Right, we then iterate through all those group nodes, and as long as it's not a nested group, we then add it to change nodes. We change its position, applying the delta. And I think we should have had the logic. I got the logic wrong last week. I think, as in, is it plus or minus? But the fact I've copied it down, I should have got it right this time. And that, I think that's good enough for this to work with groups. So let us find a flow that's, we can try and make some sense of whether it is genuinely working with groups or not. Here we go. If I create a group like that and select these things and say horizontal, distribute selection horizontally, it's not done anything. Okay. Try that again. Yeah, so it's not done anything. Let's just change some of the debug we're spitting out to help us figure out why not. Okay, let's say console.log nodes to move. Let's make sure the fact we have a group now isn't upsetting things this early on. Then we'll log out the nx, ny target, target, and also is group, just so we know we're, oh yeah, there's the bug, n. So I copied and pasted this line from previously, where earlier things were called n, down here things are called next node. So I could persevere and add some more debug just to be sure, but I can also be confident that that's an obvious enough bug as far as I'm concerned that that could explain what we saw. So let us have a go. Just try and make it obvious if things move. N is not defined. Okay, so I must have accidentally left another n in there, yeah. Nx and y. Yep. See, I fixed it in one, but then completely didn't spot these guys. Right, any more n dots in this code? No. Okay. There we go, distribute horizontally. So we can see from this edge of the debug node, 2.5-ish grid cells to the edge of the group. And on this side, just over 2. In fact, without it selected, it's much clearer. You can see 2 3/4 grid cells on that side, 2 3/4 grid cells. So the grouping has worked. If I were to group that one as well, that's an interesting test actually, because suddenly the group is a bit bigger because of this node button. Interesting. It's pushed it further back. Why did it do that? What's happened there then? Let's try and work this out. So as a user, I'd expect that middle group to move cleanly into the center. And you can see it's not quite calculating the start and end right. So interesting. What we're going to do is no. Yes. Space to fill. This is the bug. So this is just calculating the difference between the x's and the y's to work out how much space to fill. If one of the ends is a group, then we're no longer calculating from the center of this one to the center of this one. We're calculating the center of this to the left-hand edge of this, because that's where its x-axis is. So we've got to take into account groupiness of all of this stuff. Right. There are reasons why group's x-axis is the top left corner. I'm beginning to wonder whether if the amount of code I've had to write to take that into account now outweighs whatever benefit there ever was having them work like that, but I digress. So we're going to have start anchor x start anchor y, end anchor x, end anchor y. Go away. Then if start anchor dot type is a group, then start anchor x needs to add start anchor dot width, half the width, and the y half the height. And we do the same again for the end anchor. All good. And then down here, we want to take into account end anchor. Yeah, I'm going to stop saying it out loud because it's a bit of a tongue twister. Although saying it out loud, make sure I don't make a mistake. So if it's horizontal, it's the delta of end anchor x and start anchor x, or otherwise vertical, it's end anchor y and start anchor y. Good. And then, in fact, we can then simplify this code down here, because we can say, yeah, we don't need this logic down here anymore, because we now have start anchor x and start anchor y already take into account the groupiness. Okay, I'm just going to hit deploy on that just so I don't have to recreate these groups. Let's move stuff around so it becomes obvious. Okay, now how's that looking? It is, again, slightly strange to look at to see the gap. The gaps are different. But if we go back to our old friend PowerPoint, why don't we approximate? So that's our inject node. We've then got a biggish group, which, oh, and we can do this on grid cells. 1, 2, 3, 4, 5 cells for that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So over 2.5 times the width. So this guy is 3.7 centimeters. So if we make this sort of, oh, yeah, it's all, no, that's too big. That big, and then this guy is 1, 2, 3, 4, 5, 6, and 8. Oh, I've lost track of what this should be, so let's make that big. Nope, don't delete it. So now if I select those and distribute horizontally, and just get another little shape just so I can measure these widths. So that's how big the gap is on that side, and that's how big the gap is on that side. Now if I make this one much bigger, and say distribute horizontally, the gaps are the same. So that's interesting. I've ended up implementing something different. If we had something tiny and select all those, say align, distribute horizontally, and then measure all these gaps. Yeah, so it's distributing the space between them. It isn't aligning the center points of each of these objects. Look, if that's the distance between those center points, you can see the distance between these center points is much less. So I've implemented the wrong thing. Cool. Let's fix it. Okay. So what are we going to do? We've implemented the wrong thing. What we really want to be doing is we need to work out how much horizontal or vertical space the nodes are using. So what's the total width of that plus the total width of... No, we don't. We've got the start and end anchor. We need to find its edge, and that gives us the space to fill. And we have to do it based on their edges, not their centers. Once we've got that, for all the things inside it, we need to calculate their width and take the width, the total of their widths away from the total available space. That gives us the amount of space to distribute for the gaps in between them. Okay, so let's go back through this. So start anchor X and Y. So we want to find the right-hand edge of it. So what we're going to say is the right-hand edge, if it's a group, is if it's a group, then we add the complete width or height. Else, no, I'm losing. Okay, so that's going to give us the right-hand edge, whether it's a node in that instance or a group in that instance. Yep. Then for, oh, it's going to be so much, it's rife possible copy and paste errors here. So for the end anchor, we want to go the left-hand edge, so we have to take away half the width, half the height for regular nodes. Else, if it's an anchor, what we actually just need to send them to X and Y. No further calculations needed. Now there's a bit of reordering to be done here to reduce superfluous calculations, but I'm just sticking with this for the moment. So now the space to fill, that's logic is still the same. It's now the gap between their edges. What we now need to do is calculate the total width of all the nodes we want to be moving. Rather than iterate down here, we can add a bit of logic. Up here. So this is where we were filtering out our start and end anchors to get our list of nodes to move. Well, given this is already an iteration through all the nodes, we can add some extra logic in here before we, if you say return true inside this if statement, that means it's a node we care about. It is not the start anchor or end anchor, or return false, which will filter out the start anchor and end anchor. But now we can do some extra logic. We want to calculate the node width, which, yeah. Okay, well, I'm going to persevere in calculating. There's a bit of mix here of sometimes we only do it on one axis, sometimes we do it on both. Again, ripe for some optimization and code reduction, but I'm just going to run with it for now. For both nodes and groups, we don't need any if else's. We know the widths and heights, so we can just sum them up. So space to fill is all of that. Well, the space to fill now is the difference between the end anchors X and the start anchors X, which is their edges, minus node widths, and that one minus node heights if we're working the vertical axis, and then space between nodes, that logic is still sound. It's still divide that by the number of nodes plus 1. But we need to change our logic down here slightly. So our starting point is going to be the right-hand edge of the start anchor, and we jump that much. But we're jumping that much, that takes us to the left-hand edge of the node we want to place. Which means we need to move its so now we've got another group width half to take into account. Which I can picture in my head, and I'm trying to vocalize it so you guys can follow, but at this point, given it's 10 past already, I'm just going to charge ahead. Apologies if I've lost you in terms of where we are in the physical coordinate system. So this is where start anchor X is set to. We add our space between nodes, which gets us to this point here. Now for groups, that's fine, because that's where we want the group to align. But if this were a node, we've got to take into account half of the node's own width. We need to translate the target by the next node. Okay. Hopefully some of you are still watching. Okay, so once we've done that and we're ready to iterate, what we now need to do, because the TX is no longer... Yeah, I'm just going to add in below this if statement. If it's a group, then TX, we need to jump to the other side of the group. Else, if it's a regular node, we need to make another half hop to get to the edge. Right. Let's refresh. So let's start on this guy again. Just deal with nodes first. Distribute horizontally. Let's have a look. So we've got 1, 2, 3.5. That looks good. 1, 2, 3.5. That looks good. So that has done the right thing. What will be interesting is let's drop in this node, this change node, which is bigger than the get node. And let's have a look. Are they... So now we have 3 cells between those two nodes, 3 cells between those two nodes, and 3 cells between those two nodes. You know, that actually, oops, if I select all of them and look at me, look, if I do align to bottom and they all line up, see, that actually looks good. I should have done this as a test case before I started this rewrite, because this isn't... That's nicely horizontally distributed, whereas before I think this node would have been over here slightly because it would have been trying to align the centers evenly rather than the gaps between nodes. Yeah, this is already making much more sense. Let's try our friend the groups, and with a group at the end. Well, it's not worked, but okay. Yeah, it has not worked at all. Right, was that... Let's get rid of the group at the edge. Let's see what edge condition we're falling off here. Select all them. Okay, so we aren't handling groups properly. Out of interest, there we've 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 13 grid cells to this edge. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 13. So it has stuck the group's right-hand edge where the group's center should have been. So I've got somewhere here, I've got a plus minus half a width in the wrong place. Right. Excuse me just whilst I go quiet for a moment, I've got to rethink this logic. So start X is set to the right hand edge of the group, of the start anchor. We know that's working. TX and TY, we line up to that edge. Then, if we're going horizontal, we move TX the space between nodes. So we should now be TX should be, well, TX is where we want the left-hand edge of the next node to hit. So we want to get the nodes, yeah, okay, here it is. We shouldn't be, because it's the left-hand edge we care about, then yes, this logic is off. So TX is where we want the left-hand edge to be. For a regular node, oh, which way around are we going to do this? Sorry, TX is where we want it to be. Oh, no, okay. I'm going to say this a couple more times out loud. I think we don't want this. Yeah. If it's not a group, then the target is midway through the node. If it is a group, then the target and NX are all just fine. Yeah, I think that was the bug. And then we readjust down here. Yeah, that's the half width that had gone awry. So select them. Distribute selection horizontally. Now that's looking good. I like the look of this. We've got 1, 2, 3, 4, 5, 6, 7 3/4. 1, 2, 3, 4, 5, 6, 7 3/4. Yeah, that's worked. So now let's put that one in a group and try again. Yeah, see, it's nudged it very slightly. We've got 1, 2, 3, 4, 5, 6, 7 on that side. Here we've got 1, 2, 3, 4, 5, 6 3/4 and 7. Yeah, so that's worked. Let's make this one a group, because I don't think we've ever tested having group at the start. So here we've got 1, 2, 3, 4 and a sliver. Yeah, that's about 5. This side we've got 1, 2, 3, 4. Yeah, and 5. Yeah, they all line up. That's all good. Cool. Shall we quickly check vertical? Just for fun. So yeah, you can see we've got 3 cells there, we've got 3 cells there, vertical's working. Awesome. So that logic is all good. There is the question of, let's just have a look. This is line 534 down to 691. So this is 160 lines of code. I think I might just do a little bit of pruning, such as say node space. Because, you know, there's just a bunch of stuff, a number of values we're calculating that we just don't need to do both axes all the time. Down here, we are going to swap this round. set it to those, and then if the anchor type is not a group, then we subtract that. Yeah, it's slightly different there, but that's yeah, live with that. Live with that. So I do lots of TX and TY. Do we really need TX and TY? Maybe not. I could probably reduce that just down to 1, but then it would mean more if statements down here. So yeah, I'm not going to worry too much about that. I would, having just made those couple tweaks, I'm just going to go double check that it still works. Yeah, that worked. Ooh, no. Pressing all the wrong keys. You think I know how to do this by now. Now that went wrong. That has gone wrong. Notice that distance is, I think, 1, 2, 3, 4 and a bit. 1, 2, 3, 4. Oh no, it didn't go wrong. Beg your pardon. Don't convert to a subflow. That's not what I want. Yeah, that's worked. Okay. I think that's good enough for tonight. The only question is, do we want to add some default keymaps? Why not? So I've been using Alt-A as the sort of accelerator for the align actions. And conveniently, they're all nicely distinguishable by a single letter. So we can do horizontal and vertical. Oh, I'll get rid of that. Yeah, that was that extra comma it was telling me off for. Distribute Alt-A, H, V, so that's all good. So let's say, well, let's find an example. Yeah, let's do these ones, our old favourite. So I do Alt-A, H, and it's lined horizontally. Good. All right. Yeah, I think that's everything. As I said, there's going to be some odd cases like this, where if I select all that and do align horizontally, rather than straighten the flow, it's push them further out. So there's something to be said, but not right now, to make that selection, that sorting logic a bit smarter. But the trouble is, there's all sorts of odd edge cases that may or may not make sense. So, like, what does that do? Yeah, this isn't about trying to improve sort of intelligently layout. All we've done tonight is fairly simple logic once I got the maths right for aligning stuff. It would be neat if we could come up with an algorithm that detected that these two should be unwrapped and that it made sense to do so. But I think that would have to be almost a separate action, a different type of sort of smart distribute rather than just the default distribute type of action we've done tonight. Okay, is there anything else to look at? No, I think we're pretty much covered. Steve, next week's Smartline. Next Monday is Bank Holiday Monday. I am not going to be... So, public holiday here in the UK. I won't be streaming. I'm actually away for the day with the kids. Last bit of summer holidays before school starts up for them next week. So, yeah, no stream next week. I'll be back in 2 weeks. Keep an eye out for the stream archive as I eventually get there and figure out where we will share this. I've noticed I've been fairly impressed with some of the timings here. Like 4 weeks in a row, I ended within a minute of each other, almost to the second in a couple of them. But there we go. Yeah. What else to say? Nothing. We're done. It's time for me to hang up. What I should do is, just for completeness, let's add the commit, add distribute horizontally, vertically actions to editor. Yes, this is just the formality, doing the paperwork. This is one of the nice things with the streams. If you are following along and you wanted to play with this stuff, all of that code is now part of... Oh, did I push the right... Yes, I'm in the right... heart-stopping moment. Was I in the right branch? Yes. So, pull request 3110 now has all this code in. If I refresh. So if you fancied having a play with that, fancied doing some more with it, then by all means have a look. What I will do is add in to our description. And this is something I'm trying to do more of, is making sure that, even if it's me raising the pull request, make sure the description does a decent job of describing it, because often, like in the changelog, I include references to the pull requests where there are pull requests, and often, it's an opportunity for people to learn more about the features and see what's what, because the user guide website will add a section all about these actions and they exist, but people don't read the docs. Yes, it will be in the release notes, but I just trying to get more in the habit of this type of stuff, spread the information as many different places that people are more likely to discover it. So just looking at the to-do list, there was one around align selection to group. Should it apply to nodes inside groups? Still haven't thought about that. And we want to add a main menu. So depending what's what in 2 weeks' time when I'm back streaming, it might be we spend a bit of time looking at the menu, looking at how we add a new sub-menu with align actions. There's actually some design work I want to do around how plugins can... there's already an API for things to add things to this menu, but it's a bit of a Wild West API that it's not very clean. So maybe, no promises, maybe in 2 weeks' time we'll look at the next task on this, which is adding in a sub menu for these view tools, because things like zoom and reset zoom and these buttons down here don't appear in the menu anywhere, which isn't necessarily a bad thing, but there might be other things we want to add in the future. Yeah, no, might do that in 2 weeks' time. Cool. Well, I'm going to say goodnight. Thank you all for joining as ever. Thank you for persevering. I hope that's interesting. Looking at my OBS screen, I can see I still need to sort out some of the theming of the Twitch chat sidebar in the live stream. Some bit of nasty contrast going on there. I'll try and remember to do that as well. Otherwise, I'm going to say good night and see you all around next time. Bye.